guys, welcome to my channel. Hello fellas, very welcome. We are starting today the new course of derivatives. Okay, in this first lesson and in every lesson we will check some theory and some exercises until we can master the derivatives. Okay, so if you don't have any idea at all of how to derivate, this is the good channel and this is the good video because it's the first lesson. I hope you will get used to my crazy way of teaching, but if you get used to it, you will see that it's very effective and that you will learn a lot. You will finally master this crazy world of the derivatives. Okay, so to begin this course, this lesson, I will explain. I need to explain, it's very important, what a derivate is, okay? So for this purpose, I need to draw the axis, the x-axis and the y-axis, okay? This is the two-dimensional plane, and I just need to plot any function. For example, this one, okay? This is the function, I will call it f depending on x, okay? fx. From now on, I will tell fx. Okay, the name of this function is fx because actually it depends on the value of x, because for this value of x, for example 2, when the x equals 2, the value of the function is this one, is the value of the y, okay? The y in this case might be whatever, this, but this is the y, okay? And if the x is, for example, 4, here, you get up, and this is the value of the function for x equals 4. So for this reason, we say that this function depends on the x, and this would be the y function, the result of the y for this x. Okay, so this is very important because the derivative of a function measures the slope of the tangent line of the function in each point. For example, the derivative of the function when x equals 2 is the slope of the tangent line to the function in the point x2. This is slope, the inclination of this line. Okay, but if we look for the function in x equals 4, the slope is bigger. We can see that the slope increases. Okay, so the tangent line is this one. We can see the slope is more pronounced. Okay, so this is what the derivate measures. Okay, so I explain this because it's very usual to find the functions when we are trying to calculate a derivate. For example, we can find y equals 5x, or we can find fx equals 5x. Every time we find fx or every time we see y is the same, okay? Because the y is the value of the function fx. We can call them both y or fx. Both are the same and both are alright. Okay, so how do we express a derivate? I will always write y, okay, instead of fx, but if you want to write it fx or if you see fx, it's alright, it's the same. So we can express the derivative, for example, as derivate from the y, we are derivating y, and we are always derivating respect x, because x is the variable, okay, the dependent variable, and we always derivate respect this one, respect x. Okay, we can write this like this, or we can write it like y with this line here, okay, y prime, and this is the same. And so this is the notation for the derivatives. It's very important to know it, and I'm going to start this lesson with the theory and some exercises for the constant derivative and for the power functions derivatives, okay? So the first and very important thing is that if we have any constant, for example, I will write it with a c, any constant might be any number, 4, 5 or 6.8 82, and any constant value, the derivate, I could write it like derivate of c on x, depending on x, or I could write it like just c prime. The derivate is always 0. This is very important. The derivate of a constant is always 0. Why is this happening? What's the reason for this? Yeah, because if the function is a constant, for example 4, if the function is 4, it means that for every x, for x2, the value is 4, here, 4. And for x4, the value is still 4, is here. And for x8, the value is still 4. That's why it is a constant. So it's a horizontal line, and the slope of any tangent line is horizontal, and it has no inclination. It has not an angle, so there is no slope, and because the derivative measures the slope is 0. This is the reason, okay? Well, now it's very important also, if our function is x, okay, the x function would be this one here. I'm going to draw it. I like to draw it because, you know, when I was a kid, I always wanted to be an artist, a painter, and I couldn't succeed, so now I like to draw for you. This is the x function. I will call fx equals x. Is this function, this line 45 degrees, okay? You see, for when x is, for example, 4, if y equals x, it means that y is also 4. So the derivative of y depending on x, the derivative with x, it's very important, is the derivative of x respect x, and as you can imagine, this is 1. This is very, very, very important, okay? So the derivative of x with x is always 1. This is so important. It's the most important thing of the derivatives, of the basis, okay? And with this basis, we are ready to, sorry, my fellas, this is getting a little bit dark. With this basis, we can start to explain the derivatives of some other functions. Okay. If we have, for example, a constant, for example, our function is some constant, the number 4, multiplying x. How we derivate this? Okay, this is very important, that always when we have a constant multiplying a variable, this is the variable, the constant goes outside for the variable, so we can write here the constant 4, and we may multiply the derivative of x. Which one is the derivative of x? With respect to x is 1, so 4 multiplied by 1 is 4. So the derivative of any constant multiplying the variable x is just the constant. The derivative for x is just 4, and the derivative of 45x is, for the same reason, 2045. Okay, this is also really important. Everything is important, as you can see. You must be a little confused. Why is everything so important? But actually it is. Okay. Which is the next important step? Okay. The next important step, after we know how to derive constant, well, we know the derivative of constants are the most easiest. It's always 0. We know how to derive the identity function. It's just the dependent variable, and we know how to derive a constant multiplied by the variable. But what happens if this variable is a power function? For example, we have x squared, or we have 5x power 3, for example. How could we derive this? Okay, for this there is a formula, and this formula you can check them if you look for any I don't know, in the internet you can find for these rules of derivatives. You just need to find the rules for derivatives. You can find all these formulas, and I'm going to write the one for the power functions. It's very important that you learn this formula. You will always need it from now and the rest of your life, this formula must be one of the most important for you, okay? So, just let's set up this a little bit, okay. If we have the function y equals f(x), any function, power a, okay, this is the power of the function, how could we derivate it? The derivative would be y prime equals a, okay, the a goes down here, multiplying a, you see go down, it's a way of speaking, but it goes down, it multiplies the f on x, it remains like it is, then the power is a minus 1, and then we have to multiply by the derivative of fx. So I would write here f prime fx, okay? So this is hugely important, okay? It's massive. We need to learn this as the hand of our, the lines of our hands. So let's give some examples, some easy and some more difficult, and we can finish this video. And believe me that this is the really basis of the derivatives. So, for example, if we have this x squared, x squared, the derivative would be, you see, the fx is just x, and the a is the square. You see that, the number 2. So the square, the number 2 goes down here. So we write it here. Then we write the fx is just the x, and we write the power, but we need to decrease 1 unit. So it's 2 minus 1 is 1. So the derivative is 2x. You see, the 2 went down. So it was very easy. But if the function is 5x power 3, we just need to proceed the same. The 3 goes down, multiplying. Okay, we remember what I told you first, that if there is a constant, the constant just stays out, and we derivate the variable. The constant is 5, it stays out. We derivate the x power 3, and we multiply everything together. So, just applying this formula, we need to identify the fx is the x, and the a, and here you have also to multiply by the derivative of fx. But if the fx is x, the derivative of x is 1, as I told you before here, okay? So for this one, the 5 is a constant, it goes out of the derivative, and the fx is x, the power, the a is 3. So the 3 goes down, multiplying also the 5, that is a constant, we don't touch it, and then the fx power minus 1, 3 minus 1 is 2, and multiplied by the derivative of fx, f prime x, but fx is x, so the derivative is 1. We just multiply by 1, is the same. So the derivative of this function is 15x squared. I think this must be very easy for you. So let's show some more difficult examples, the last two. Okay. Well, let me think of any easy example. Okay. Let's make it a little more complicated, okay? If we have this function x squared plus 2x plus 1, and the power is a half. 1 divided on 2, okay? This is a half. So you may be now a little confused. I'm going to write again the important formula that we all need to learn and to remember. Is this one: if y equals fx power I, the derivative y prime is a multiplied by fx power I minus 1 multiplied by f prime x. So we need to identify first what is in this formula, what is fx. Fx is all this formula, x squared plus 2x plus 1. This is fx. And what is a? A is 1/2. This is a. So if we want to derive this, we just need to proceed with this formula. Again, it's always the same. So the a goes down, the a is 1/2, so we put it here. Then the fx remains like it is, x squared plus 2x plus 1. And then the power is I minus 1. How much is 1/2 minus 1? 1/2 minus 1 is the same than 1/2 minus 2 divided by 2. This is 1. And this is the same as minus 1 divided by 2 minus 1/2. So I would write here minus 1/2. And we need to multiply this by the derivative of fx. If fx is this formula inside, we need to multiply by the derivative of this formula inside. So I will put here into parentheses the derivative of this is applying exactly the same rule. The 2 goes down, 2x multiplied by the derivative of x, that is 1, 2x, plus the derivative of 2x, the 2 is the constant, and the derivative of x is 1, so plus 2. And the derivative of 1, because it is just a constant, is 0, I don't write it, plus 0, I don't need to write it. So this would be the derivative of this function. I have just applied the chain rule. This is the name of this rule when you start derivating from the outside and then you finish derivating the inside. And this is the derivate rule. It could be a very long one, but this was easy and short. Okay, I'm going to show you the last example, a little more difficult, but it's always the same. So I think after this video you must be ready to derivate any constant or any power function, okay? So if they would give you this equation, 6 divided by 5, x power 3 minus 9x plus 4, and the power is minus, I'm going to make it a little more complicated, minus 3 divided by 2. So just we need to identify these parameters of the formula. Fx would be everything here, and a is minus 3 divided by 2. Minus 3 over 2. So if we want to derivate this, it's just the same as always. First, the a goes down. The minus 3 divided by 2 goes down here. And we just put the fx, is this the same as it was? 6 divided by 5, x power 3 minus 9x plus 4. And then the power, we need to decrease 1 unit. So minus 3 halves minus 1 is the same as minus 3 divided by 2 minus 2 divided by 2. This is minus 5 divided by 2. So I would write it here, minus 5 divided by 2. And then multiply by the derivative of fx, as it says here. So which one is the derivative of fx? Applying again the chain rule and derivating this as we did with this formula. We can, the 3 goes down here, so it would be 3 multiplied by 6 divided by 5. Okay, this is the constant, we leave it outside, so that's why I wrote it here the same. I need a parenthesis here. And then the x, the power is 3 minus 1 is 2. Then I need to decrease 9. Okay, just 9 because the derivative of 9x is 9 and the derivative of 4 is 0. I don't need to write it. Okay, this would be the derivative of this function here. It's so easy, but maybe a very crazy and old mathematician would punish you if you just write it like this because it's not beautiful. You can read on the numerator any function with a negative power. This is forbidden for crazy mathematicians. So you would just need write in the numerator the positive powers like this, 3 multiplied by 6 divided by 5x squared minus 9, and then this negative power must go to the denominator. So to the denominator it goes this function, 6 divided by 5x power 3 minus 9x plus 4, and big I here, you must be very careful. This is the big I here, okay, with the eyelashes. You must look this, you cannot forget about this. If in the numerator the power is minus 5 divided by 2, in the denominator the power is 5 divided by 2, positive. But this is the same as writing here, the denominator, the square root of 6 divided by 5, x power 3 minus 9x plus 4, and everything power 5. Okay? Here is the 5, this 5, and the 2 is here, because it's the square root, and this is the 2. Okay? Well, I hope you like this video. Please, I would ask you to subscribe my channel, to like this video, like the channel, and of course I will keep uploading videos in English. We will learn together all the mathematical philosophy. Just I asked you to share the love, to spread harmony against the brotherhood, and to teach mathematicians in the street to everybody that seems to be wanting to learn it. Goodbye. Goodbye.